بسم الله الرحمن الرحيم والصلاة والسلام على أشرف الأنبياء والمرسلين نبينا محمد وعلى آله وصحبه أجمعين. Today inshallah we are going to start with chapter 5, design. It's called design. So it is a little bit combined for the materials of week 3 and 4. So we are going to mention the key points under each one of these topics. So it is on your shoulders to study them in details from slides and from the supporting materials like the textbook and other online materials. So let's start with the introduction. Then we are going to go through the organizational support for design, the design process, design frameworks, design methods, need to differentiate between them, and then we are going to conclude with design tools and interaction patterns, social impact, and legal issues. Let's start with the introduction. The design in general can be heard and used with many topics other than the computer related topics, but generally and loosely here it can be defined as the outcome or the process of creating specifications for synthetic artifacts such as products, services, and processes. So generally or broadly, it is the process from the beginning of collecting the requirements, the specifications of a product throughout it is development processes to the end of the final stage and having the final product. Okay, so it is not only related with physical forms or physical artifacts of computing as hardware like computers and others, but also with other softwares even that are logical, not rather than physical. Okay, so usually in the past, throughout the history, usually the design is usually the design tends to be like more rigid, fixed, following ABCD steps. But in our era nowadays, we are more towards dynamic and interactive design. Okay, so it is nowadays more agile than it used to be 10 or 20 years ago. Okay, agile mean here, I think that you know the concept, like quick, fast, more dynamic. Okay, so all interfaces or hardwares or softwares that we design or we interact with, they have some features that are more comfortable to users than others. So early computer applications were designed by programmers to be highly functional for the programmers themselves. So they don't pay that much attention to the end users themselves. Okay? Now, in the current generation, the end users are on the focus. They have to be satisfied with their usage and utilization for specific program or any interface. So they will continue using them, and their productivity may be maintained or even improved. Okay, so we should have such an effective interaction design that takes the intended end users as its starting point and focuses on facilitating the function of the artifact. So we need to collect the need, the requirements, the specifications from the end users. Either they are going to just purely use it or to administer it. Through those requirements, we have to design our programs to be functional as well. So satisfying the end users without functioning software or hardware, it is useless. And the other hand, if we have functional hardware or software without satisfying the end users, it will be semi useless, or it will be cumbersome to use. Okay, so professional interaction designers carefully observe their users. They collect their requirements, their needs. They interactively refine their prototypes based on thoughtful analysis that suits the end users. They systematically validate their interfaces through early usability and acceptance tests. So they are not just living and working at their offices without any interaction, without any evaluation, without any testing from the end users. So the function that a specific object or a specific digital object, a specific interface is intended to do is not the only important matter, but even the user, how the end user is going to utilize them, how he will feel while utilizing them. Is he going to be happy to continue using it? Okay, and so on. So the function is not the only important aspect here of a digital object. The form is another aspect, and it sometimes comes in conflict with function. We have on one side, on the one hand, it can be argued that good form will facilitate function, whereas it is true that highly convoluted form may inhibit function. Let's take an example. Consider a kitchen cabinet door with no handles. There is no handles for that cabinet, or the door inside the kitchen, but its appearance is sleek and appealing. However, it lacks visual indication of how and where to open the door. Is it going to be easy to use, or it will be confusing for anyone who is going to utilize them? So the key to good design starts in the organization itself. The organization will specify the functions that they are aiming at, and the end users will specify, on the other hand, the specifications of their security, their convenience, and satisfaction, and so on. So the primary reason is that design is unpredictable. We cannot sit as programmers at our offices and then we said no, yes, the the user will use this and this and this and this and he will satisfy, and that's it, without doing proper requirement specification and evaluations. So the organizational support here for design, the design is inherently creative and unpredictable. Not every design will suit every single user or every group of users. So interactive system designers must blend knowledge of technical feasibility with mystical aesthetic sense of what attracts them to use that system, especially if we have alternative applications or hardware or softwares, and we need our software to stand out against the others. Most companies around the world may not yet have chief usability officers, CUOs, or vice president for usability. However, some companies are beginning to employ chief design officers, which may help to promote usability and design thinking at every level. So, organizational awareness about the importance of the usability design is important, and this can be raised by presentations, internal seminars, and so on, in order to raise the organization awareness about the importance of the usability design or the design usability. It is even nowadays can be linked to raise that awareness. It can be linked with the investment, the financial matters. So some tools or some points or aspects that can be used to persuade the organizations to pay due attention to usability or to design usability is the financial issues. return on investment. If we can convince them by proving the return on investment, it will be a convincing point for organization to support the usability design. In terms, for example, on the retention of customers, that if our product is more usable than other competitors, so we may be able to retain, to keep our customers, and then we may have more revenue or more return on our investments than others. Okay, nowadays we can even have these positions or these professions, like they are called usability engineer or user interface architect or UX, user experience team, and so on. They are being created and on different organizations, and hence they are raising the awareness and doing their best with even the UX professional association. So what about the design process? Let's talk now about the design process. One way to define the design is by its operational characteristics, like the scenario based. Design is a process. It is not a state. It is not just the final product. You see it, oh, it has a good design. But how has it come to this state, to this form, to this shape? The design process is non-hierarchical. You cannot have it on a hierarchical stages that one should follow the other from top to down or from bottom to up without taking an iteration, for example, or a cycle. So the process is radically transformational. It involves the development of partial and interim solutions that might be evaluated, tested, and may ultimately play no role in the final design. The design, the final design might be totally different than the initial one. So the design intrinsically involves the discovery of new goals. By the time of evaluating, testing the prototype, you may find out a new goal for that, or a new feature, or a new difficulty that needs to lead us to go back a little bit on the design process to change either by adding or omitting some of them. So these characterizations of design convey the dynamic nature of the process, as we mentioned earlier. So the interactive design process based on the operational definition. Usually it has four distinct phases or stages, in other words. After the inception, the beginning, the start, we have the requirement analysis here. Then preliminary and detailed design, implementation, then what we have implemented, we are going to evaluate it based on the results of this evaluation. We may need to go out to requirements analysis, then to design, implementation, and so on, till we are satisfied with the final product, so we can take the design forward to the deployment. So this is the main phases that you are going to use in the real world and even on your assignment and project this semester. So the primary feature of this process is that it is iterative and cyclical. Said that this is the iteration. So it is not 1, 2, 3, 4 like linear one, but it is iterative. So it is not like the waterfall model where one phase is leading to another one and to the end. There is no way to go back. The waterfall model can be utilized, but the final product might not be as satisfying, as effective as if we use the interactive design process. Okay, so there are several cross-cutting factors that contribute to each phase of the cycle, including academic and user research, guidelines and standards, and tools and patterns. Each one of these stages will have its own requirements, standards, guidelines. So let's start with the first phase, the requirement analysis. The requirement analysis, usually it is when we gather all the necessary requirements for the system or device that we are going to design, and at the end of this stage we will have a specification, requirement specifications document as an outcome. So we are going to start, gather the requirements, and then we will have a documentation for that. So the documents here is very important to have a clear specification of the user community and the tasks the users perform. If the software or the website or the hardware that we are going to design is aiming at specific group of people, specific user community, so we have to target them by our requirement analysis gathering. If it is, for example, let's say a registration software, so we have to ask both the registrar or registration specialists and the students who are going to register or to use this for registration. It is not that important to ask, for example, the general public about it, the purely academic staff that they are not going to interact with the software or website at all. Okay, that document can have three main components: functional requirements, non-functional requirements, and user experience requirements. The functional requirements, from its title, again, try to use your common sense. It defines specific behavior that the system should support, like use cases. Okay, now let's take the use case that the student now is going to register for a new course. So what functions are needed here? The 1, 2, 3, 4, 5. Now let's use the use case of deleting a course. Use case of creating a section from the admin registration site, and so on. So the use case is a formalized scenario that captures an operation between an actor, human, and the system in a step-by-step manner. So we need to make these steps as efficient as possible and as less as possible, as few as possible. So the other component is the non-functional requirements. Non-functional. Now we are not taking a functional one, a specific use case or scenario of usage, but these are other operational criteria that are needed for that system, such as the hardware specification requirements, software, system performance, reliability, and so on. The user experience requirements, it is kind of non-functional, but it is related to the user interface mainly, like the navigation, the input, the colors that we talked on about them on chapter 3 in the last chapter. This is an example that you can go through that is related to an ATM, a website, and mobile application. Read it and study it carefully so you understand what we are talking about. So to do so, we have to do so to collect the requirements and analyze them. We have several methods, including ethnographic observation, focus group, and user interviews. Common among all of these is that they are intended to monitor the context and environment of real users, either in action or on their own words. So we need here to put a scenario and ask the user to state, either if we don't have any initial prototype, to state what he needs and the steps that he is going to follow, or if we have a prototype or even an old system, that we can observe the users while interacting with that, and ask questions and specify requirements based on that. The second phase of the design process, after the requirement analysis, we have the preliminary detailed design. So we can have a preliminary or a detailed one. Usually at the beginning we have a preliminary. In the first iteration or in the first cycle we have a preliminary design where the high level design or architecture of the interactive system is derived. So it is like an initial, in other words. Then maybe on the second or third or whatever iteration, we may reach the stage of a detailed design, where the specifics of each interaction is planned out, and where the next stage, next phase will be more useful. So the preliminary stage is also called architectural design, the architecture of the system, or conceptual design, conceptual map of concepts such as users, controls, user display, and so on. One difficulty in designing interactive systems is that users may not have a clear idea of what the system will look like when it is done, if it is just conceptual. They might not be able to visualize how is it going to be. Unfortunately, it is difficult, costly and time-consuming to make major changes to systems once those systems have been implemented. So that's why it is important to have this at an early stage. Some of the difficulties can be avoided at an early stage by giving the customers or users a realistic impression of what the final system will look like. How? By using suitable design methods, including sketching, paper mockups, and high fidelity prototypes. Based on the nature of the interface that we are going to design, we can decide which one can visualize or can simulate the final product in order to make the testing or the evaluation of that design more realistic or closer to the real world, where all the planning of the preliminary design is there. We need now to go further to the third phase where we build and implement the actual design, the actual interface based on the requirements analysis and the preliminary or detailed design. So the actual software and hardware engineers needed to achieve this are outside the scope of this book. So we are not going here about the software or hardware requirements in details here, as it is out of the scope of this book, but we are going to need them, of course, while we are implementing a real software or hardware. So regardless of the platform, make sure to evaluate the tool capabilities, ease of use, ease to learn, cost and performance, most of which we talked about them on the last chapter, in chapter 3. Tailor your tool choices to the size of the job. After the building and implementation, we are in the final phase of the design cycle. Developers test and validate the system implementation to ensure that it conforms to the requirements and design set out earlier in the process. So The evaluation here will be based on the requirements and design set at the first and second phase of the design cycle here. Based on that, we decide whether there is a need for another iteration to amend, to customize them. There's something missing or something additional that it is not needed, so we are returning it back, or we proceed to the final production or deployment. Okay. And these are examples about if it is web designers, for example, how they must carry out many small and some large pilot tests of components before release to customers. They have to follow specific procedures of evaluation that they vary, they differ, they are different from one interface to another, depending on the goals of the usability study, the number of expected users, the danger of errors, and the level of investment. We are going to talk about a range of suitable evaluation methods in the following chapter, inshallah, on chapter 5. But let's focus here more on the design in general. So what about the design frameworks? We have different design frameworks. The design frameworks, it is the specific flavor and approach the design takes to conducting the design process. What it is like, in other words, the main drive of the design process of the design cycle that we have just mentioned. Okay, here it can be user centered. Okay, it can be user centered design, UCD. It can also be participatory design, PD, or an agile interaction design. Let's briefly talk about each one of them. From its title, user-centered design, user-centered. So the main focus here on the user themselves, on the users themselves. Definition: it prescribes a design process that primarily takes the needs, wants, and limitations of the actual end users into account during each phase of the design process, during each phase of the 4 phases that we have just mentioned. So the benefits of user-centered design: it gives designers a much needed understanding of what their users actually need. It reduces both the deployment time and the cost of maintenance later on. And most importantly, it reduces the risk of designers building a wrong system, a system that the end users neither need nor ask for. And this will be a waste of resources in general, time and cost and so on. User-centered designs practices help organizations align system functionality with their business needs and priorities. So what about the other one, the participatory design, PD, or in other words, cooperative design? It is the direct involvement of people in the collaborative design of the things and technologies they use. There are many variations of participatory design to create dramatic performance, photography exhibits, games, or merely sketches and written scenarios. For example, users can be asked to sketch interface. The user themselves who are sketching the interface and use slips of paper, pieces, and so on to create a low fidelity early prototype. And then the high fidelity prototype is created by the designers based on that. So instead of the designers themselves proposing or sketching the interfaces, the users themselves can do so, and then the designers will raise their concerns or comments on it, and they are going to customize it till they reach a stage where they can take it further. So careful selection here of users helps to build a successful participatory design experience. So not any user is suitable for this sort of participatory design. Have a look to the examples. The third method is the agile interaction design. It is a family of development methods for self-organizing dynamic teams that facilitate flexible, adaptive, and rapid development that is robust to changing requirements and needs. So usually there are teams and it is flexible, adaptive, and rapid at the same time. Quick. Yeah. It is a division of tasks into short phases of work, short time, and frequent reassessment and adaptation of plans. So the iteration here and is more, and the blocks of the tasks are smaller. These methods are based on evolutionary development, where software is built incrementally and in rapid release cycles. So the final product can be reached here at an early stage, and it is a coach for the evaluation and rapid customization or development. There's no need for a long time to be spent in order to take it again to the beginning of user requirements or the design. So instead of costly and time-consuming documentation, high-fidelity prototype and usability evaluation and workshops that are common to heavyweight design processes, agile interaction design will use sketches, low-fidelity mockups, and fast usability inspections. And the benefits are clear here. I think it enables practical and pragmatic design, short development cycles, and dynamic designs that are responsive to changing needs. Have a look to this YouTube clip at your own time. So what about the design methods? Design methods. So we talked about the frameworks, user-centered, participatory, and agile. Now we are talking about the methods of the design. The design methods are the practical building blocks that form the actual day-to-day activities in the design process. Most common design methods are ideation and creativity. So it is like brainstorming. Okay, surveys, interviews, and focus groups, ethnographic observation, scenario development and storyboarding, and prototyping. These are the most common design methods. Ideation and creativity. From its title again, it is one way to think about design in an incremental fixation of the solution space. So giving idea, okay, we would like to have a flight booking system. What is the ideas that we can include on this? So just open the table for ideas, for creative ideas. So it supports creativity here. There is no limit for that. We said that just the title, final goal, flight booking, or we said course registration, and so on. And let it open. Until we reach a single solution or a solution that can have many functions. Based on that, we can move forward. So gradually, it is reducing the solution space while having convergence or convergent thinking. It is like designing by similarity, let's say, with other similar systems, with particularly for teams of designers who each bring their own expertise and visions to the table. It's good in one way, but it's a problem that it may employ the risk of imposing conformance and uniformity too early in the process. So if we are using convergent thinking, so most likely we are going to create something that is very convergent or similar to an existing product. Okay, because we are limiting ourselves to a specific product or specific idea. So to avoid such local optima, there is a need to introduce an opposite type of thinking, which is divergence or divergent thinking into the design process. It's the opposite of convergent. Divergent, like insimilarity. We are thinking about having a flight booking system. In the first method here, convergent, we are thinking about making it similar to a current one. But here we are thinking about things that are not available on a current or an existing system, which may lead us to be more creative here. So this is like a potential solutions considered with if we are using divergent or convergent. See that if you are using divergence in similarity, we can have too many ideations. But if you are tending to have it convergence and you are thinking about conforming with what we are having or what we know, it will be limited and so on. We can use a hybrid one of them, mixed one. We can start with divergence and then convergence to to put us on track and so on, and go back to divergence and convergence and so on, till we reach the final product. So the ideation here, or idea generation, for such divergent thinking, in that they require designers to test their limits, abandon their assumptions, and reframe their problems. So in the divergence one, more creativity is needed, more openness is required as well. And brainstorming is one of these. One example of the divergent thinking. The other one is surveys. The second design method: surveys, interviews, and focus groups. So the most straightforward way to elicit, to collect, to gather requirements and desires from users is simply to ask them. Ask them, either by surveys, either online or paper. The survey is the simplest and cheapest approach, and simply enable distributing a questionnaire to representative users. These representative users are considered as sample. If your end users is not that much, you can use all of them if there are a few of them. But if you have a large number of potential users, you can get a sample or representing sample. The other one, interviews, in-person interview, either face-to-face or even online nowadays. They are more labor intensive, they consume more time than surveys, but will yield more accurate and high quality responses. Interviews can take place either in one-to-one, one-on-one setting between a designer and a user, or focus group discussion with multiple users and designers. The choice between individual or group interviews depends largely on cost. The interviews can be conducted in different ways. It can be conducted in structured or unstructured or semi-structured. Structured, again from its title, they are essentially verbal surveys. They are preset questions. Okay, the designer will set the question, will preset the question before the interview, and then during the interview he will ask the users the questions and will record or write them down, the responses or the answers. Unstructured, they have no specific questions at all, but it is generally a discussion about the design itself of that product between the designer and the user. Semi-structured, it merges both structured and unstructured. There are preset questions, but there are some open-ended questions, and there are some other questions that they may emerge based on the discussion or based on the answers of the user. Okay, it is more flexible one here, as collecting unsolicited feedback as well as getting answers to specific questions that the designer didn't know, or those questions didn't come to the mind of the designer, but they are important to the users. The ethnographic observation, it is the systematic study of people and cultures. So it is more related to the human and their culture or community itself, society. So it is designed to explore cultural phenomena where the researchers observe society from the point of view of the subject of the study. So one product, there is an assumption that one product may work well with a specific culture more than another culture. It may work in a specific context rather than other one, specific environment rather than other one. So interaction designers differ from traditional ethnographers in that, in addition to seeking understanding of their subjects, interaction designers focus on interfaces for the purpose of changing and improving those interfaces. Whereas traditional ethnographers immerse themselves in cultures for weeks or months, interaction designers usually need to limit this process to a period of days or even hours to obtain relevant data needed to influence a redesign. So there is a need for a preparation in order to do an ethnographic study. For interaction design, there is a need for preparation and field study. Preparation like understanding the organization policies or work culture, familiarizing yourself with the system and its history and so on. The field studies establish rapport with managers and users. Observe or interview users in their workplace and collect subjective or objective, quantitative, qualitative data. Analysis of these collected data after compiling them either in numerical, textual, and multimedia formats. Some of them can be qualitative and others can be quantitative. So they need to be interpreted and analyzed. And they have to be reported. Consider multiple audience and goals. Prepare a report and present the findings in order to see whether we need to redesign or make any customization to our design or not. The fourth design method here is scenario development or storyboarding. It builds on the use case concept and allows for developing specific scenarios when a user engages the interactive system to solve a particular task. Several additional methods of scenario development are useful, like flowchart for each use case. For example, there is a flow chart processes or transition diagram or sequence diagram and so on. Storyboarding is similar concept, but it is the use of graphical sketches and illustrations to convey important steps in a scenario. These are examples of the sketches, or let's say the hand-drawn storyboard. Finds the data is synchronized, is notified, user can analyze together, and so on. Based on that, these can be presented to end users or a sample of end users, and then we can discuss them further. The fifth common design method is prototyping. Prototypes or physical sketches are particularly powerful design tools because they allow users and designers alike to see and hold for physical prototype representations of the intended interface. It shouldn't be exactly the same as the final product expected, but it is supposed to be like a tangible one that the user can interact with, that it assimilate the final product. See here, for example, that this device can be hand drawn or hand built from cartoons or paper, for example, in order to evaluate, for example, its size, its movement, the positioning, and so on. The realism, the realistic of the prototype, the closeness to the realism is called fidelity. The closeness of the prototype to the final product is called fidelity. For our prototype governs the time investment in creating it. So it depends on the budget and so on, the available tools and so on. We can have different level of fidelity. We can have low fidelity, medium, and high fidelity. Low fidelity are generally created by sketching, using sticky notes, cutting or gluing pieces of papers and so on. This is low, so it is far from the final product. Medium fidelity are often called wireframes and provide some standardized elements such as buttons, menus, text fields, and so on. Whereas high fidelity, it looks almost like the final product. So it is closer than the final product. And it may have some rudimentary computational capabilities. However, the prototype is typically not complete and may not be fully functional. What is the relation between design frameworks and design methods? Specific design frameworks have an affinity to specific design methods. For example, participatory design or user-centered design tend to incorporate a lot of ethnographic observation, whereas agile development employs sketching to a high degree. Design frameworks also provide a flavor for the overall process and each of the design methods. For example, an agile approach to sketching will focus on collecting quick ideas from the design teams, whereas UCD or PD will let the intended users themselves to be part of the sketching process. Okay, let's move to the design tools, practices, and patterns. And as these tools are changing, so we are going just to mention the main points about them. Design tools, they are known. They are dedicated prototyping design tools, dedicated for designing, for the purpose of creating interface mockups. Okay, whether for desktop, mobile, or web. Some of the tools will be used in our project, such as Balsamic, if you want, or any other, or Adobe XD for prototyping. But you are free to use any other tools that can serve the purpose while you are doing your assignment or project. So the design guidelines here and standards. Guideline documents are powerful tool for interaction design. There are four E's. Four E's guidelines that provide a basis of creating a living guidelines document and a lively process. So what are these four E's? Education, enforcement, exemption, enhancement. Education, users need training and the chance to discuss the guidelines. Developers must be trained in the resultant guidelines. Enforcement, a timely and clear process is necessary to verify that an interface adheres to the guidelines. Exemption, where creative ideas or new technologies are used, a rapid process for gaining exemption is needed. Enhancement, a predictable process for review, possibly annually or semi-annually or whatever, will help keep the guidelines up to date. So the interaction design patterns here, they are best practice solutions to commonly occurring problem specified in such a way that they can be reused and applied to slightly different variations of a problem over and over again. So a pattern approach to interaction design would suggest reusable solutions to commonly occurring problems in user interface and interaction design. So we should follow a specific pattern. It shouldn't be like random. Now we are following this, and after 1 week we are following another method, and so on. There should be an iterative pattern for that. So an example of useful interaction design patterns is document interface patterns. Many applications allow opening more than one document at the same time. Document interface patterns capture different ways of managing multiple documents for an application. We can follow single document interface, multiple document interface, or tabbed document interface. So read about each one of them, and this is just an example. So there is a pattern that should be followed. If you are following in our design or for this system single document, we should keep that pattern. If it is multiple document interface, we should keep it. If it is tabbed based on tabs, so we should keep it. So we are not recommended to be inconsistent, sorry. Sometimes we use single, sometimes we use multiple document interface, and sometimes tabbed. Consistency, as we said many times in this course, is very important. Social impact analysis, we need to weigh to evaluate the social impact of our design. So interactive systems often have a dramatic impact on a large number of users. A social impact statement might help to promote high quality systems. An outline for a social impact statement might include these sections. Describe the new system and its benefits. Identifying the stakeholders, the benefits, the goals, address concerns and potential barriers. So we shouldn't leave the users, the end users, finding out the capabilities and the limitations of this product. We should include even the security and privacy issues. We should outline the development process. It should be documented clearly in order for enabling future iteration. Finally, the legal issues should be stated clearly, such as the privacy and security concerns, safety and reliability, copyright or patent protection, freedom of speech, and so on. So this is all what we have about this chapter. Thank you very much. Assalamu alaikum.